Welcome to Fred
and Amy's Math
Math
Shack.
Hi, what I'd like to do is look at this set of axes, x and y, mostly this is the positive quadrant for both. We'll go into the negative quadrant slightly. We've got a line, this red straight line here called L. We've got 2 points, A and B. And what I'd like to do is think about what we could find out in this situation, all the mathematical things that we could write down. Pause the video and have a go. I'm going to show you a few now, and maybe you've got some extra ones. So we could write down the equation of L. We could write down the equation of a line that's parallel to L and passes through a different point. I've just happened to pick 4 minus 1. We could calculate the length, any length along the line, AB for example, leaving your answer exact. You could also round it to say 3 significant figures. Calculate the angles that are formed from the triangle that are made. So I've gone with where the line L meets the x-axis. You could write down the equation of a line which passes through a different point. That's a bit unrelated. This is off the graph. This is just testing your knowledge of a previous topic. And you could inquire whether the line L is parallel to another line. Just off the top of my head, like other ones you could do is you could describe the shaded region. Here, I might look at that in a bit. You could find the midpoint of the line. You could, I think that's it for the moment. I can't think of anything else. You can find the area of the triangle. Like there's so many mathematical things we could do. So what I'd like to do now is see if you can answer these questions and any of the other ones that you came up with. I'm not going to go through all of them in detail, but I am going to give the answers now and talk about them a bit. So we can work out that the gradient is -1/2. I go along 2, down 1, and we can see that the intercept is 4, so we can get the equation of the line. For a parallel line, we know it's going to be y equals minus 0.5x. You might write this as -1/2. I've done it as a decimal here. 0.5x plus c, and you could substitute the point in and work out the value of c. It's 1. To work out AB is going to be Pythagoras' theorem. It's going to be 4 squared plus 8 squared, all square rooted. That will give me the square root of 16 plus 64. That's the square root of 80. And that can be cancelled down. Oh, wait. I've written 80 there. That can actually be simplified as a third. And I'm just going to remind you about that. So you can find the largest number that goes into it, largest square number that goes into 80. And I think it's 16 times 5. You can write that as root 16 times root 5, and so it actually becomes 4 root 5. Now, fine if you wrote root 80 in this case, but be aware of simplifying thirds as well. Calculating the angle, we get 26.6 degrees. Best thing to do, you could use that exact length, but probably the easiest thing, because what if we'd made a mistake, is use the ones we can easily read off. So the opposite is going to be 4, and the adjacent is going to be 8. So we can write down that tan x is equal to 4 over 8, and we can do inverse tan of that. And you could also then do angles in a triangle and work out this angle if you wanted to. Equation of a line passing through 2 points, find the gradient. I go 2 along and 6 up, so it's going to be a gradient of 3, and I can substitute in one of the points. I get 3x minus 29, way off the graph, but that's how we can do it algebraically. And is line L parallel to this line here? We can rearrange it, and it becomes y equals minus 0.5x plus 3. So yes, because they have the same gradient, this one here and this one here. Midpoint, I think I'll talk about this very quickly. So actually, from the graph, we can see the midpoint between A and B is going to be here, exactly halfway in between. So it's going to be 4, 2. You can actually do that by taking the coordinates individually. So we've got for A, we've got 0, 4. And for B, we've got 8, 0. And you can add the x coordinates and divide by 2. That will tell you halfway through. So 0 plus 8 is 8. Divide by 2, we get 4. 4 plus 0 is 4, divide by 2, and we get 2. This works in general. And then finally, I think this is one I did talk about. I'm not going to find the area of the triangle, but to describe the shaded region, it's going to be x greater or equal to 0, y greater or equal to 0. I'm going to put a comma there. And then at the moment we've got all of this region, but I just want to include everything under the line. So it's going to be y is less than or equal to 0.5x plus 4. Today we're going to look at perpendicular lines, and what that means is lines that have a right angle between them. Now we've looked at parallel lines. That's when essentially they have the same gradient, and I suppose they have an angle of 0 degrees between them, because they're exactly the same. Here there's an angle of 90 degrees, and whilst with parallel lines we draw little arrows to show that they're parallel, for perpendicular lines, if you were like demonstrating it via a sketch, you would actually put a little right angle on it, and then you'd see that they are perpendicular. And just like there's a relationship between parallel lines, they're the same gradient for parallel, there is a similar, or a different, I should say, actually it's not similar, it's another relationship between perpendicular lines, the gradients between them. And that's what we're going to try and discover in this lesson and then use. So what I want you to do is pause the video and calculate the gradients of each of these lines and work out, say what you notice. And if you start noticing a pattern as you go, then make predictions as you go along and see if it works out. So if I look at line A to start with, I go along 2 and down 1. That gives me a rise of -1 for a run of 2. It gives me a gradient of -0.5. For B, I go along 1 and up 2. That's 2 over 1, or 2. For C, I go along 3 and down 3. That's -3 over 3. It gives me a gradient of -1. For D, it's a slightly shorter line. I go along 2, up 2. It's a gradient of 1. G, I go along 3 and down 1. It's -1 over 3. For H, I go along 1 and up 3. It's 3 over 1. Remember, it's rise over run. Don't forget that. It's 3. You might start making predictions now about what's going on. Like, have a look at these numbers. I'm going to keep going. Okay. For this one, for E, I go along 1 and up 4. It's going to be 4. I'm going to make a prediction with my head and see if it works. Okay, and this one, I go along 4 and down 1. It's -1 over 4. Yep, my prediction worked there. And then this last one, I go along 2 and down 5. That's actually -5 over 2. Okay, this is slightly different to all the other ones we had. So I wonder if you can make the prediction about J. It's going to be I go along 5 and up 2. It's 2 over 5. And this is what we find. Find that when two lines are perpendicular, the product, that means when you multiply them, of the gradients is -1. So -1/2 times 2 is -1. -1/3 times 3 is -1. -5 over 2 times 2/5 is -1. It's always the case. So, and when a graph has gradient m, a graph perpendicular to it has gradient -1 over m. This is the key, absolutely key result from today. If they're parallel lines, you get the same gradient. If they're perpendicular, then you take the gradient and you do 1 over that and you make it minus. This is known as the negative reciprocal. So you might sometimes say, well, yeah, you just take the negative reciprocal. Reciprocal means 1 over. Negative just means you stick a negative in front of it. You can write it as -1 over m as well. The minus doesn't have to be in the numerator. Okay, that's typically how I write it. So this works for all of them. Like when you have 2, it works. You do -1 over 2, but it does work the other way around. If you do -1 over -1/2, it actually takes you back to 2. You're finding out how many halves go into 1, that's 2, and then you've got a double negative going on. The same happens for the other ones. Maybe this one's the most confusing to see. You would do -1 over 2/5 if you're taking that 2/5. And then you can write it as -1 divided by 2/5. And this is a case where you're dividing a fraction, so it would become keep, change, flip. It would be -1. Sorry, my pen's not quite giving me the 1s as I wanted it to. -1 times 5/2. Keep, change, flip, and then you see that you can write this as -1/1, by the way. Then you get -5/2. So it works there as well. And I suppose in general, like the more you get a feel for this, you can basically just take the number, flip it round. Okay, because 2 is 2/1. Like if it helps, write it as 2/1, flip it round and make it negative. Yeah, this one here, 1/3, make it negative. -5/2, flip it round to 2/5, make it negative. Double negative takes you to 2/5. And that's what we're going to practice here today. I haven't proven this fact, and the proof that I know of goes into quite some complicated detail involving similar triangles, but I'm going to give you, at the moment I've only demonstrated it works for some of them. It does work for all of them, and I'm going to give you what I hope is a bit more of a convincing argument now. So I'm just going to draw a triangle, and although I know it's on going across 1 square and 2 squares, I want you to kind of forget about the squares and just take it as a line by itself. And then here I've got the run, and here I've got the rise. And what I'm going to do is I'm going to just copy it to start with. Right, I'm going to label on that run and the rise. So rise here, run here. The gradient of this black line is going to be rise over run. Maybe I shouldn't call it, I'm going to take that back. I'm not going to call it rise over run. I'm going to call it, I think I'll call it A over B. Yeah, why not do that? So M is going to equal A over B. Right, now if I take a triangle that looks exactly the same, just going to make it red instead. No, let's make it green. Right, if I took this triangle with gradient of A over B and I rotate it 90 degrees, by definition that will mean that it's a perpendicular line, because they did have 0 degrees between it. If I rotate it 90 degrees, then suddenly they're going to have 90 degrees between them. And if I move it slightly, what I see now is that here it's going down by this amount, but that will be equivalent to my B from before. So actually it's going down by minus B, and it's going along by positive A. And so the gradient of this line is going to be minus B over A. And I've done this now just a little bit more algebraically. I've taken a line, I've given the rise and the run certain names, I've just called them A and B. I've rotated the triangle by 90 degrees, trying to ignore the squares, the fact that it is 2 and 1. I see that I will get a perpendicular line, and then suddenly the rise that I had will become the run, and the run that I have will become the rise, except I just end up with a negative gradient if I had a positive one to start with. And so this, I hope, has convinced you, if you weren't already convinced, because I'm definitely working more generally now, that in general, if you have A over B as your gradient, then for a perpendicular line, it's minus B over A. For the rest of this lesson, we're going to be using this key fact from today, the fact that the gradients of perpendicular lines multiplied to give -1, or equivalently, if you got the gradient of one of them, you just take the negative reciprocal of the other. And we're going to be applying that to similar sorts of questions that we've looked at previously. And you'll see what I mean in a minute. So I want you to kind of work through this with me, pause the video, have a go, and then just see if you agree. And let's make some good progress on understanding perpendicular lines. Okay, if we're finding the gradient of a line perpendicular to this one, then we take the negative reciprocal, it's going to be 1 over 8. Here, negative reciprocal, minus 5 over 2. Here, I first need to get the gradient, so it's going to be 3y is equal to 15 plus 5x, or y is equal to 15 over 3 plus 5x over 3, using knowledge of rearranging equations from previous. And I can write that, I can rewrite it as 5 over 3x, good to put the x first, plus 5. I don't even really care about this. This is the thing I care about. That is the gradient, 5 over 3. So my answer here is going to be the negative reciprocal minus 3 over 5. How about this question? Which line is perpendicular to this one? Well, the gradient is 4, the negative reciprocal is minus a quarter, it must be A. How about this one? Bit more work to do, so 3y is going to equal minus 2x plus 12. Divide through by 3. At this point, do I really need to do all that? I can see that I'm going to get minus 2 over 3. Yeah, you can get the equation itself if you want to, and sometimes you'll need to. The negative reciprocal is then going to be 3 over 2. That will give us the perpendicular line. Okay, and now I'd like you to try this exercise. So this is just continued practice of this kind of skill that we're using. But go for it. Like if you're really confident, fly through it. If you're less so, then take your time working out negative reciprocals. I'm going to show you the answers now. So for number 1, we just take the negative reciprocals. This is what we get. Minus 0.5 is minus a half, so it would become 2. Just be careful when it's decimals. You have to convert it to fractions. So k, you have to realize, is actually, well, it's 2 over 10, which is 1/5, and then that becomes minus 5 with the negative reciprocal. Just one to be aware of is 0. If you've got a horizontal line with a gradient of 0, then actually the gradient of the perpendicular line, sometimes we say it's infinite, but really it's better to say it's undefined. And then for question 2, write down the gradient of any line which is perpendicular to this. This is again back to rearranging equations. It's just that this time you work out the gradient of this line and then you take the negative reciprocal. Okay, on to questions that are of a similar nature to previous, but now we're not being asked whether lines are parallel or to show they're parallel. We got this other kind of similar question, show that they're perpendicular. Have a go. Okay, best thing to do in both cases is get the gradient. So I can write down for P that 5y is equal to 2x plus 13 by rearranging. So y is going to be 2/5 x plus 13 over 5. I've divided both sides through by 5, and I've straight away written it as 2/5 x. Okay, I'm just taking it's okay to go straight from there to there once you become confident. If you want to do extra steps, go for it. M is then 2/5. So to show that P is perpendicular, I need to show that the other line has a gradient of minus 5 over 2. That's my negative reciprocal. So in this case, it's going to be 6y is minus 15x plus 21. Actually, note there's a common factor of 3 here, so I could, if I wanted to, divide through by 3 at this point. You don't have to, but I'm going to get that. And then I'm going to get that y is equal to minus. I'm going to divide through by 2, just like I did similar up here. And then you can either say that they're negative reciprocals, or you can write down that 2/5 times, this is a good way of doing it, times minus 5 over 2 is equal to minus 1. So they are perpendicular. It does say show that, so again, you need to be convincing. Okay, try some similar questions now. I'm not going to go through all of these, but I'm going to show the answers. This is how they would link up. Show that they're perpendicular. You get the two gradients, you multiply them together. A little bit more words than this, but this is a summary of what you would write. Okay, what about number 5? So number 5 is getting even more involved now, because first of all, we actually don't need to find the equation of the line going from AB. All we need to do is get the gradient. It's minus 4 over 3. And then we need to rearrange this equation to get the gradient, which can be done like so. You get 3 over 2. And then in this case, you would multiply them together, show that you don't get minus 1, i.e. they're not perpendicular. Okay, let's keep going. Okay, this is a similar sort of question. So get the gradient of the line AB, which in this case is 2. I haven't shown working for it. Rearrange this equation to get the gradient of minus a half. Show that when you multiply them together, you get minus 1, and therefore, yes, they are perpendicular. And this question here, line L2 goes through these points. Are these two lines perpendicular? You must show your methods. This is a very similar sort of question, but they're giving us a graph this time. So you have to work out the equation of L1. And here's the answer. So for L2, you can get the gradient using methods we have, doing rise over run. You should get minus 3 over 2, which is minus 1.5. I'd probably, to be honest, I would leave it as a fraction. I think I'm going to go through that in a little bit more detail, just in case you've forgotten. So for AB, I could do 7 minus 2 divided by minus 5 minus 1, and that's going to be 9 over minus 6, which becomes minus 3 over 2. For the other line, all I need to do, I don't need to know the equation of the whole line, I just need to sort out the gradients. And I can see, okay, I need to pick a point where it crosses the axis perfectly, and I think it goes through there. I think I can be pretty confident and say that. Just need to be careful here, because actually, although there are 6 squares, it's actually a run of 3, because the scales are not the same. And then actually the rise is 2, so I get 2 over 3, and then I can show that I multiply them together to get minus 1, and again I show them perpendicular. So we've introduced perpendicular lines here. We've seen this key result that you must know about the negative reciprocal, and then we brought in all the kind of stuff we've seen before, you know, using 2 points, getting the gradient, and basically like just reinforcing, rearranging, and show that questions. Okay, I hope you're happy. Keep practicing this, and next time we're gonna take it a little bit further again, using the idea of perpendicular lines.